In this video, we have a variety of questions that deal with trig ratios, and we're also going to float in some concepts of similarity too to help us come up with some answers. So the first question is asking us to come up with the cosine ratios for all the non-right angles. So all the angles that do not equal 90. So I'm going to start with this triangle right here. And angle G is the only angle that has 90 degrees. So we're going to use B, and then we're also going to use N. And I'm going to pull up SOHCAHTOA 2 to come up with our formulas for cosine. So the big C is going to represent cosine, and then the A is the adjacent side, and then the H is going to be the hypotenuse. So we're going to use adjacent divided by hypotenuse to come up with our ratios. Now to help us set up the adjacent side over the hypotenuse, I like to call out all my sides. So for angle B, 13 is the longest side of the triangle. That's going to be our hypotenuse. I always like to call out that side first. And then I like to call out the opposite side. And the opposite side of B is going to be the side that you could draw an arrow to, and it'll hit that side. So then 5 is going to be the opposite side, but we don't want that in this situation. The side that is adjacent to or next to angle B, or kind of like the leftover, is going to be 12. That's going to be our adjacent side, and that's the one we want in our numerator. So in the top we have 12, and then of course we have the hypotenuse labeled there as 13. So that's going to be my trig ratio for cosine of B. Now for cosine of N, we use the same formula. It's going to be adjacent divided by hypotenuse, and our 13 is going to be our hypotenuse again, and our hypotenuse does not change. Again, it's always the longest side of our triangle, so if we use a different angle, it's still going to be the same side. But now I'm going to get rid of my green stuff here because I want to clear the way with all my blue writing. I'm going to draw my arrow across from the angle, and it's going to hit side 12. So now 12 is going to be my opposite side, which we don't want, but I'm just trying to label all the sides again. And our adjacent side is going to be the one that's next to angle N, and it looks like that's going to be 5. So to write my ratio, adjacent side is 5, and the hypotenuse is 13. So that's my trig ratio for cosine of N. I'm going to do the same thing for this triangle down here, for triangle KDL. K is going to be one of my non-right angles. I'm going to do this a little bit quicker now. The hypotenuse right here, 26, is the longest side, so that's going to be in the denominator. And then drawing my line across, 24, that's the opposite side, but we don't want it. And then the leftover here next to K is going to be the adjacent side, that's 10. So that's going to be my fraction. And I could reduce this. The number that divides into both of these numbers is 2. So 10 divided by 2 is 5, and then 26 divided by 2 is 13. So that's my reduced fraction. And now I'm going to do cosine of L. Circle that. And I'm going to get rid of my orange to make my L stuff clearer. So once again, the longest side stays the hypotenuse. So that's going to be 26 in the denominator. And then drawing a line across from angle L, that's going to be my opposite side, but I do not want that. I want my adjacent side. So that's going to curve over here. It's going to be 24 is my adjacent side, and I put that in my numerator. I could reduce this one as well. 2 also divides into this fraction, so 24 divided by 2 is going to be 12, and 26 divided by 2 is going to be 13. So I have another trig ratio simplified. Now I answered the first part of my question. I have all the cosine ratios, and I want to compare them now and draw a conclusion. So it looks like cosine of B is 12 over 13, and then cosine of L is going to be 12 over 13. So it looks like I could match up those two together. So if cosine of B equals cosine of L, and I'm using the same trig expression cosine, I think that we could say that angle B and angle L are going to be the same. So I could write angle B right here corresponds with this angle L, and they're going to be identical, congruent. I also see that 5/13 right here for cosine of K equals 5/13 here for cosine of n. So I could write cosine of k equals cosine of n. And just like I said that B and L, those two angles are going to be congruent, it looks like N is going to be congruent to K. So I could write K right here is going to be congruent to this one. And it seems like we have corresponding angles that are all congruent in this triangle and this triangle. So then we could also say that these two triangles will be similar because by angle, we've proven that they're similar. And there's my similarity statement. Triangle KDL is going to be similar to triangle NGB by the angle similarity postulate. Alright, on to this next question. Let's roll with the whole similarity thing. We have two triangles here, right? We're trying to prove if cosine of G, so G is right here, is going to be equivalent to cosine of S. This one right here. So it almost looks like those two angles match up, right? And it's also nice that we have all the sides of each triangle. So maybe let's see if all of the corresponding sides are in proportion. So I see that the hypotenuse here is 20, which matches up with this hypotenuse is 25. So I'm going to do 20 divided by 25, see what that equals. And then this side right here, 12, matches up with 15, so I could go 12 over 15. And then 16 matches up with 20. So I could write that fraction out too. So let's see if all these are the same. If they're the same, then it looks like all the corresponding sides have a, well, they're all going to have the same proportion, they all have the same ratio. So we could say that they're in proportion. So I know that a 5 divides into both 20 and 25. So 20 divided by 5 is 4, and 25 divided by 5 is 5. So that reduces to be 4/5. I know that 3 goes into both of these, so 12 divided by 3 is a 4. 15 divided by 3 is 5. And then I know that a 4 goes into both of these, so 16 divided by 4 is 4. And 20 divided by 4 is 5. So it looks like all these ratios right here simplify to be 4/5. You could also convert that into a decimal if you wanted to. And if you do that, you're going to get all them equaling 0.8. It doesn't matter how you do it, but the point is that all the corresponding sides have the same ratio, so we could say that these two triangles are going to be similar. And the thing we know about similar triangles is that all the corresponding angles, so D and R, and then more importantly G and S, are going to be congruent. So if we're trying to prove that cosine of G and cosine of S are equivalent, well then we know that G is going to be the same thing as S, so these ratios would have to be equivalent. But let's say we didn't know anything about similar triangles and we just want to figure out what cosine of G is. Well, cosine, if you use SOHCAHTOA, means that we go with the adjacent side divided by the hypotenuse side. So the adjacent side to G is 12 and the hypotenuse is 20. So there's that. And then for S, the adjacent side is 15 and the hypotenuse is 25. And there's that. So we know that these two fractions are going to be the same because if we reduce them, 12 over 20 ends up being 4/5. And if we reduce 15 over 25, that ends up being 4/5 as well. Okay, finally, last question. We want to figure out what the missing variables are. So I'm looking right here at my small triangle and I see a right triangle, and I know that we have two sides, so whenever we see that, you could use the Pythagorean theorem. That means that we take one of the legs, square it, and then add that to the other leg squared, which will equal to the hypotenuse squared. So the legs that I'm going to use here are stemming from my right angle. So going this way, that's a leg, and then going down this way, that's a leg. So it looks like X and 3 are my legs. So there we go. I square them and I have them added together. Now the hypotenuse is going to be my last side right here. It's the longest side of the triangle, which is 5, so I have to square that. It's also the value that my equation will be set equal to. So now I have to solve this. So I'm just going to bring down my x squared, and then 3 squared is 9, and 5 squared is 25. Okay, now I want to take away 9, so I subtract that, that goes away, and I take away 9 over here. I'm left with x squared equaling 16, and then to undo the squaring of x, I'm going to take the square root of both sides, and then my answer is going to be x equaling a plus or minus 4. However, this value for x can only be a positive 4 because obviously we can't have a negative for the side of a triangle. Okay, now we want to figure out what y is. Well, y is going to be a part of the hypotenuse of this huge triangle right here, right? And then we also have this little triangle. So whenever we have a small triangle and maybe a bigger one and that smaller one is inside the bigger one, you want to look for similar triangles. So we could see that angle A here is going to be an angle in this small triangle, and then we also know it's going to be an angle in the big triangle. That's going to be the big triangle right here. So because angle A is in both of them, that's going to be one, I guess, pair of congruent angles, you could say. And if we could find another one, then we could say that these two triangles are similar. And we do have another one. It's going to be the right angle right here. So in this small triangle, you have this right angle. And in the big triangle here, you have another right angle. So by angle, we could say that these two triangles are going to be similar. So there's my similarity statement. And if you're thinking, well, wait, why do we even have to do that? Well, again, y is a part of the hypotenuse of this big one. So we could set up a proportion to figure out what that y is. And the proportion is going to be 3 over 5. So let's start by writing 3 over 5. And then that's going to be set equal to the side that is corresponding with DE. So DE in that smaller triangle is going to be matched up with CB in this bigger triangle, and that's going to be this side right here is 9. So I put that up in the numerator. And then 5 is the hypotenuse, and that matches up with the hypotenuse of this big triangle right here. So that's going to be 5, and then it's going to be plus this y, because 5 plus y is that entire big hypotenuse. Okay, now at this point, this is when you would cross multiply. So you'd take this 3, multiply it by the 5 plus y, and then take this 5 and multiply it by the 9. So there's that. Now we got to distribute this 3. So 3 times 5 is 15, and then 3 times y is just going to be a positive 3y. 5 times 9 is going to be 45. We want to keep solving this, so we want to take away 15 from that side, take away 15 from the right side, and we're going to be left with a 3y equaling 30. And then you want to undo the multiplication of 3 by dividing it, so that goes away. Divide the right side by 3 as well. So I'm finally left with y equaling 10. So this is going to be 10 right here. So there's my two unknown variables of x and y. And the last part of our question is asking if cosine of angle DEA is going to be equal to cosine of angle CBA. So DEA is going to be this angle right here, right? And then cosine of angle CBA is going to be this angle right here. And these are the corresponding angles of the similar triangles, right? It looks like this one right here would be angle E, and that's this third letter. And that matches up with angle B right here, which is this third letter. And if we know that these two triangles are similar, we know that the corresponding angles also have to be the same. So if we know that DEA is going to be the same as CBA, then these expressions have to be equivalent because we're using the same trig expression. So that's one way you could do it. If you want to actually figure out what those trig ratios are, you could do that as well. And I will do it really quickly here. Cosine of DEA is going to be the adjacent side, which is 3 divided by 5, which is the hypotenuse. So it's the adjacent side divided by the hypotenuse, which is 3 over 5. And then for CBA, the adjacent side for this big triangle, according to angle B right here, is going to be 9. That's the adjacent side to B. And the hypotenuse to B is going to be this entire side here. It's 5 plus this part, which is 10. So 5 plus 10 is going to be 15. And you could reduce this. 9 and a 15 can be divided both by a 3. So if you take 9 and divide it by 3, you're left with 3. If you take 15 divided by 3, you're left with a 5. So as you can see, our trig ratios are the same. And we expected this too, because we have already said that these two angles were going to be the same. So of course the trig ratios would be the same as well.